So, today we're going to learn about angles. So, this is going to be Unit 1, Day 3, right? So if you want to do the top of your notes, if you want to match it to the video, it's Unit 1, Day 3. All right. So, an angle. An angle is formed by two rays with a common endpoint. So, an angle takes two rays to make an angle. So, I have that ray drawn on the board over there. And if I draw another ray coming off the A right here, that would make an angle. Okay? So an angle is formed by two rays. All right. The endpoint that they have in common is called the vertex. So the point where the two rays meet is called the vertex. So we see over here, in this example they gave us, B right here is the vertex. Okay? On mine, if I draw a ray off of that, my A will be the vertex. Okay? The actual rays are called the sides of the angles. So the vertex is the endpoint in the middle of both the rays. The actual rays make up the sides of the angle. So this middle is the vertex. The two rays make up the sides. Okay? When we name an angle, we need to use three letters. And the middle letter is always the vertex. So it doesn't matter which order when you're naming the two endpoints, but the middle one better be the vertex. Okay? The other 2 points are just points that are on the rays. If we only have one angle in our picture, like this one, you could just call this angle angle B. Okay? So we could call this angle angle ABC or angle CBA. So if you use three letters and you need to put the vertex in the middle, or since this is the only angle in this whole picture, you call it angle B. But if you have more than one angle, then you don't need it. You need to use three letters. Okay? All right. So make sure the middle one is the vertex. All right. If you're talking about the measure of an angle, you're going to use a little m outside of the angle name. So that's something we need to add to our symbol sheet that I forgot. An M with the angle name means the measure of angle ABC, and that's talking about degrees. So if you see the little M in front, they actually want the degrees. Okay? The little M is in front of the name. They want the degrees. So on this one, the measure of angle ABC is 60 degrees. Okay? All right. There are 4 types of angles based on measurements. Y'all know what they are by looking at these pictures? Acute, obtuse, right, and straight. Very good. So this one right here would be acute. And that's when the measure is less than 90 degrees. It's smaller than a right angle. When the measure of the angle is less than 90 degrees. So what kind of angle is the second one? It's obtuse. What about the measure of an obtuse angle? It's greater than 90 degrees. It's more than a right angle. Okay? And then this one is a right angle. We show right angles by having the little square in the corner. And a right angle, what's the measure of a right angle? Exactly 90 degrees. And if we have a straight line, it is called a straight angle. Does anybody know the measure of a straight angle? 180 degrees exactly. Okay, so you can think about that as two 90 degrees put together. Okay. So the next examples are just going to give us some pictures of some angles, and we're going to talk about some characteristics of those angles. Okay? So on example 1, they have this angle right here. Question A says, name the vertex of the angle. What point is the vertex of that angle? K. Y'all understand why K is the vertex? It's the middle point. Okay. Name the sides of the angle. Okay. Now let's think about this. What makes up the sides of an angle? Rays. And how do we name rays? The end point and then to the one going up. So the end point of both of these rays are what? K. So KL with the line with one arrow is one end point, is one ray. And the other one is what? KJ with the ray symbol. So your end point has to go where there's no arrow. Does that make sense? Okay. And so the order matters when you're naming a ray. All right. This angle could have 3 possible names. Okay. This is the only angle in this picture. Would you call it this angle K if we wanted to? Right. And if we use the 3 letters, we have to make sure K goes in the middle because K is the vertex. So angle JKL is one correct answer. And what's the other correct answer? LKJ. I hate when my angles and L's are beside each other because they really look alike. And I apologize. All right. D says to classify the angle. Now, we really cannot, we don't have a protractor or anything to measure the angle. So, and this is one of those rare times in geometry, I'm going to say, what does it look like? Obtuse. Okay. Now, we usually don't assume measurements without actually measuring them or using information that they told us, but they didn't give us any other information to go over other than the picture. So, any questions on example 1? All right, y'all try example 2. All right, so A, what's the vertex of this angle? S. What are the sides of this angle? Ray SR and Ray ST. Very good. Somebody give me one name of this angle. Give me another angle, a name. RST and then angle TSR. And what kind of angle is this? Right, and we know that's for sure a right angle because it has a little box. Raise your hand if you got all those correct. Any questions? All right, good job. All right, so the bottom of that page has to do about how we talk about angles being congruent. All right? So here's a little picture over here. The measure of angle A equals the measure of angle B, then we can say that the angles are congruent. So then we would say like angle A is congruent to angle B. Nope, not angle A. Of course it's congruent to himself. Flexit property. So if the measures are equal, we say the angles themselves are congruent. Okay? Angles cannot equal angles. Measures can equal measures, but angles cannot equal angles. Measures cannot be congruent. Okay? So measures are equal, the objects can be congruent. Write that down if you have a space at the bottom and highlight it. Measures must be equal, objects are congruent. And y'all, that's just a nitpicky thing. But it's true. Okay? You cannot say that measures are congruent. Okay? And you cannot say that objects are equal. You cannot say angle C equals angle D. No, it doesn't. It can be congruent to angle D, but it cannot be equal to it. Okay? So you can say measures are equal, but if you're talking about the objects, whether it's the segment or the angle or the triangle, you have to say congruent. I know that's weird. It takes getting used to, but it's true. All right, turn to the second page. Page 2, I believe. I think I have them numbered, don't I? Okay, turn to page 2. All right, now, just like we had segment bisectors yesterday, we're going to have angle bisectors today. What did a bisector do yesterday? It cut it exactly in half into two congruent pieces, right? Right? Two equal parts. So an angle bisector is going to be a ray that divides an angle into two congruent angles. So an angle bisector makes two congruent angles, just like a segment bisector made two congruent segments. So over here in this picture they gave us, if BD is a bisector of angle ABC, then angle ABD is congruent to angle DBC. Y'all see that? Okay. So just like it just said, in the bottom, in the diagram to the right, ray BD is an angle bisector. Therefore, angle ABD is congruent to angle DBC. And do you see how those little arcs are right here in this picture? That's how you show that angles are congruent. So yesterday we saw that segments are congruent when they have the little tick marks. Okay? Angles are congruent when they have the little arcs. So if you see two little arcs, that means those angles are congruent. They're equal measures. Okay. Now we got a few more terms to look at real quick. The next one is perpendicular lines. We know about perpendicular lines, right? What's something we know about lines that are perpendicular? They intersect, and when they intersect, what do they make? Right angles. That's exactly what it is. So perpendicular lines are two lines that intersect to form right angles. So intersect at a right angle is how this one says it. All right, we're going to add this to our symbols page. I guess I'm going to have to scoot over on my board over there. The symbol for perpendicular is an upside down capital T. Upside down capital T. So in this picture, I have line L and line M, and they form a right angle when they cross. So I would say line L is perpendicular to line M with the upside down T. So on our symbol sheet, so if you see that symbol, that means perpendicular. So a perpendicular bisector does exactly what it says. It's a line, a segment, or a ray, or anything that is perpendicular to a segment at its midpoint. So a perpendicular bisector does two things. It's perpendicular and it does what a bisector does. What does a bisector do? Makes two congruent pieces. So if something's a perpendicular bisector, it must cross that line at the midpoint, right? Because the midpoint is the middle part of a segment. All right. So in this picture right here, blank is the perpendicular bisector to blank. Well, it looks like line LM is the perpendicular bisector, because so you see these little congruent marks right here? It's perpendicular to it, and you see those congruent marks, so that means it divides it in half to segment PQ. Okay. So the rest of these examples, we're kind of just answering some questions about some pictures they give us. Okay? So example 3 right here says, write another name for angle CBF. Well, let me look at CBF. CBF. How else could I name CBF? FBC. Very good. So angle symbol, FBC. Problem B says, name the sides of angle EBD. EBD. Well, what are the sides of an angle? 2 rays. So somebody tell me one ray that's the side of that angle. BE and BD. Could I answer that question without even seeing the picture? Yeah, because I know from this name right here that B is the vertex, right? So that means it goes both directions. BE is one ray and BD is the other ray. Does that make sense? So if they tell you the name of an angle, you can tell the 2 sides. Okay? Classify angle ABC. ABC is a straight line, isn't it? Okay, so it's a straight angle. Good. D says, give an example of an obtuse angle. Can somebody tell me an angle that's obtuse? EBD. Very good. Can somebody give me another one? DB. Say it again. EBF. Actually, EBF is a straight angle. ABF, yes. So there's quite a few of them, right? Also, CBE would be obtuse, would it not? Right? There'd be a few. E says, name 2 congruent angles. Somebody tell me. Okay, look for those little arc marks. Do we see any of those? Very good. Angle. Ooh, that's a funny angle sign. Angle E, B, A, and angle CBF. Okay. Are there any others that are congruent that we know? Yes. They don't tell me this top one is a right angle, do they? But they tell me this one is, and I know together they have to make 180 because they make a straight angle, right? Together. So I know this also has to be a 90 degree. Very good. All right. F says, name a perpendicular bisector. So something that crosses a segment at a 90-degree angle. Y'all see? Well, we only have one 90-degree angle drawn on that picture, right? Right. So I believe it's ray BD. Very good. All right. And I think y'all can do example 4. So we're going to skip it. Sound good? Sound good? It looks too easy. So let's go ahead and look at page 3. And let's talk about the angle addition postulate. Now, what was the gist of the segment addition postulate? What was the way I simplified that postulate? Little plus little equals big. So for segment addition postulate, it was little segment plus little segment equals the whole segment, right? Okay, same thing with angles. So angle addition postulate is going to be the 2 little angles add up to make the larger angle. So for example, on this picture they give us, I have this little angle up here, this little angle down here, but together they make angle ABC. Y'all see that? So in this one, angle ABC plus angle DBC equals angle ABC. I messed up that first one, didn't I? I'm sorry. Little plus little equals big. So if you want to write that down again, it's the same thing. except today we're doing angles. Okay, so these first two examples, they do it with numbers. So we're going to label it on our picture here. So number one, they tell me the measure of angle ABD is 48 degrees. I'm going to write in a 48. And DBC is 78. So that one's 78 degrees. How do I get the measure of ABC? Add them together, and what do we get? 116. Do y'all agree? Or is it 126? 126 degrees. So technically we should write it the measure of angle ABC equals 126 degrees. Okay? That's how you're supposed to write an angle measure. M angle name equals, and angle measures always need what? Degree sign. Angle measures always need degree signs. All right, number two. I'm going to erase this where I filled it in. It says if the measure of angle DBC, which is right here, is 74 degrees, and the measure of ABC, which is the whole thing, is 119 degrees, find the measure of angle ABD. Well, how do I do that? That's right. And what is 119 minus 74? Is it 45? So the measure of angle ABD equals 45 degrees. So if they just give you numbers, that's all you have to do. Little plus little equals big, or if they give you the whole thing, you subtract the little one you know to get the other little one. Okay? So just like yesterday, they throw some algebra at you. Right? So in this example 3, they tell you the measure of angle QPR, or PQR, I said it backwards, is 141 degrees. What is PQR? Little or big? All right, it's the whole thing, right? So how can I set up this equation to solve for x? That's right. So 13x plus 4 plus 10x minus 1 equals 141. Little plus little equals big. Now, I'm okay if you leave out degree signs when you're working an equation because that just kind of makes them a little sloppy. Just make sure when you write your answers that you put degree signs with them when you come over here and name the angles. Okay? So combine like terms over there. What's 13x plus 10x? 23x plus 4 minus 1. 3 equals 141. Then I subtract 3 on both sides. 23x equals 138. Divide by 23. What are we getting? Anybody have a calculator that can help us out with? I ain't going to fuss at you. Trying to save time. Is it 6? All right. I kind of believe you. It looks close. All right. So, how can we find these angles right here? That's right. Substitute 6 for the x's. So for a measure of PQS, that's this one. It's going to be 13 times 6 plus 4. 13 times 6 is, so 78 plus 4 is 82. So that one's going to be 82 degrees. And then 10 times 6 minus 1 should be 59 degrees, right? Make sure when you're answering for an angle measure, you put a degree sign. Any questions about that one? The next example is exactly the same, so I'm going to skip it. That one's pretty much the same too. These are all so many the same. Let's do number 5. You may get it? Okay. I don't want myself to step on it, actually. Okay, so on number 5, what's the first thing we really need to do on number 5? Label everything. Angle JKM is 43 degrees. And especially be careful and actually read the letters. JKM, JKM. That's that angle. Okay? Use a little finger dance, pencil dance, whatever with your angles, okay? Make sure you plug it in for the right thing and know which one's the big one and which one's the little ones. And then MKL is the other little one, right? 8x minus 20, and together they make JKL, which is 10x minus 11. So 43 plus 8x minus 20 equals 10x minus 11. So any questions about how I set that up? Little plus little equals big. So we got like terms. What's 43 minus 20? 23 plus 8x equals 10x minus 11. We'll subtract 8x. 23 equals 2x minus 11. Add 11. What's 23 plus 11? 44 equals 2x. Divide by 2 and get, you're right. Sorry. 34 equals 2x. Divide by 2. X is 17. All right. So x is 17. MKL is going to be 8 times 17. Somebody tell me what 8 times 17 is? I have forgotten. 136 minus 20 is 116 degrees. And JKL is 10x minus 11. So 10 times 17 minus 11. 170 minus 11 is 159. 159 degrees. Yeah, good job. I think the rest of them are like very similar. Go to number 8. We're going to skip some of those because they're so similar, y'all. Look at number 8, please. If the measure of angle ECD, listen to this, is 6 less than 5 times the measure of angle BCE, and the measure of angle, or BCE, and the measure of angle BCD is 162, find each measure. Well, that sounds like a riddle, doesn't it? Right? Well, we can figure that out. So, for one thing, BCD is the whole thing, right? So the whole thing is 162. So I need to fill in from what they told me here something about these two angles, right? So these are that's my big one. So I want to figure out the little ones. So 6 less than 5 times the measure of angle BCE. So can I just call angle BCE X? And that one, if that one is X, then ECD is 6 less than 5 times X. So 6 less than 5 times X, isn't that 5X minus 6? 6 less than means I'm taking 6 away. Does that make sense? So you see how I set that up? So then I can do little plus little equals big. So X plus 5X minus 6 equals 162. So then what? Yeah, like terms. X plus 5X is 6X. And then I add my 6 on both sides. 6X equals 168. 6 goes into 168. 6 goes into twice, 12, 48. 28 times, right? Y'all agree? Okay. So they want us to find the measure, and X is the measure of that little angle, isn't it? So BCE is 28 degrees. ECD is 5 times that minus 6. So 5 times 28 minus 6. 5 times 28 is 100 and something. 140. Minus 6 is what? 134. Did I check it? These two should add up to be what? 162, does it? Good job. Okay. Let's do 9 and 10. 9 and 10. All right, so 9 and 10 both have to do with this picture over here, right? And there's a lot of angles going on in that picture, right? So far, the ones we have seen just had like two little angles that make one big angle, right? We got lots of little angles and lots of big angles in this one. Okay, so labeling is going to be important. So number 9, ABF, which is this obtuse angle right here, is 6x plus 26. EBF, which is this little bitty tiny angle, is 2x minus 9. And ABE, which is the whole thing, right, is 11x minus 31. So how do we set that up? Very good. So setting it up is like the most important part. Y'all agree? And then you're going to plug it in, get X, and then plug it in for ABF. So is it okay with y'all if I don't finish this? Okay, so I'm not going to finish it. I just want to see y'all to see the setup. Okay? Got it? Got it? Well, then you can go back and finish it for me later. Okay? Because I'm just trying to get y'all to see the setup. Okay? All right, I'm going to erase. Because I'm going to go D. Because 10 goes to the same picture. All right, now this is important information here. Ray BD bisects CBE. So CBE is this angle. So BD slices these two into equal parts. Y'all see that? So those two angles are congruent. I'll put those little arcs there because they're congruent. And CBD, this angle on top, is 3x plus 25. Y'all with me? And DBE, which is this little angle, is 7x minus 19. Find the measure of ABD. ABD? How am I going to do that? Oh, I skipped something, didn't I? Segment BC is what? What's that symbol mean? Perpendicular to BA. Those are rays, aren't they? Ray BC is perpendicular to ray BA. So that means this is a right angle. Is it not? Okay, so I can so how can I end up getting the measure of angle ABD? This angle. All right, how can I get X?
Well, those two are equal.
Very good. That word bisected told me that they were equal, so I can set those two equal to each other. So that's what I'm going to do. So 3x plus 25 equals 7x minus 19. Is that word bisected? When I bisected that angle, I know I made two equal little pieces. Okay? And that means that if I can set them equal to each other, I can solve them for x. So subtract 3x. 25 equals 4x minus 19. Add 19 to both sides. What's 25 plus 19? 44 equals 4x. Now what? Divide by 4. What's 44 divided by 4? 11 x. So I can find the measure of this angle right here, right? 3 times 11 plus 25. 33 plus 25 equals what? 58 is that angle. And so if I want to find the measure of the whole angle ABD, I add 58 to what? Angle ABD is 90 plus 58, which is 148 degrees. Okay? So that's really as hard as it gets, is when it has you a picture and then it tells you some information about it. and you have to know what bisect means, and you got to know the symbol for perpendicular and all that stuff. So that's going to conclude notes for today. So I'm going to stop right here.